In the generator, the coil needs to move and is turned inside the magnetic field to create a current. This is why you need a handle in the generator. The coil consists of several turns of copper wire. It is in this copper wire that the current is generated. The slip rings ensure that the coil can keep turning without getting wound up, as explained in the following video.
This is an example of a copper wire and two pieces of toilet rolls that I quickly constructed to show you how the slip rings work. Now, as you can see in this contraption, the one wire is fixed to one roll over here, and then through it goes to the other roll where this one is fixed. Okay, so there is my armature. My daughter is helping me here. There we go. There's my armature going. And you see the one wire is connected to the one roll, and the other piece of the wire is connected to that roll. Now, this is connected to two carbon brushes. Now, we're just going to use two toothbrushes. Put the one toothbrush on the top there, and the other toothbrush on the bottom there. There we go. Now, listen very quickly, turn that around, and we have our two toothbrushes that touches that the whole time. So can you see, if I have that, if this was now electricity, and this one is part of the conductor, if that one, there we just go like that, that must go like that. Okay, turn, please, turn. So we had, whoopsie, there we go.
This is gonna take a while, so sorry.
Okay, there we go. So now can you see that if this wire connects to that side and that wire connects to that side, this armature can turn the whole way and the wires won't get mixed up. Okay, it's a rough example.
As explained in the video, the carbon brushes ensure that the generator continuously make contact with the wires that are connected to it. What is the difference between an AC and DC generator? DC stands for direct current, whereas AC stands for alternating current. If a generator generates a current that only flows in one direction and do not change directions, it is called direct current and a DC generator. But how does that work? In the DC generator, a coil is not attached to two slip rings, but a commutator. The commutator consists of two half rings that is attached to the coil. These two halves passes the carbon brushes that are attached to the conductor that conducts the generated electricity. Look closely at the carbon brush labeled X. First, the one side of the coil will make contact at X, and then the other side. Although different sides of the coil make contact at X, it will always be the side of the generator that moves down. So the current that is generated will always be in the same direction. If you apply Fleming's right-hand rule, you will see that the current that is generated at X always flows out of the screen. Although the magnitude of the current that is generated will change, the current will always be generated in one direction only. The energy conversion in the generator is from kinetic energy, that is caused by the turning of the coil, to electrical energy. When a current is placed inside a magnetic field, the current will start to move. The direction in which the current moves can be determined by the left-hand motor rule. The left-hand motor rule is a lot like Fleming's right-hand rule, but in this case the current is not generated, the current is already present. The middle finger of the left hand will represent the current, the index finger will represent the direction of the magnetic field, and the thumb will point in the direction that the current moves. In this case, as shown here, the current will move upward. In the electric motor, energy is converted, or electrical energy is converted to kinetic energy. The coil is attached to a power source. Once the current flows in the conductor that is placed inside the magnetic field, the conductor will start to move. The current flows from positive to negative. You will see, if you apply Fleming's left-hand motor rule, that the left-hand part of the left side of the coil will always move up, and the right side of the coil will always move down. Take a close look at the split ring commutator. First, the yellow part is attached to the positive side. There we go. Now it's the green part. Now it's the yellow part again. When the green part is attached to the positive terminal of the current will cause the coil to move down. Later, when the green part is attached to the negative pole, like here, it will cause the coil to move up. Because the direction of the current inside the coil keeps on changing. First it goes in this direction, then it goes in that direction. Then you have in this direction, and then it goes in that direction. The coil will continue to go one side up, and then down, and up, and down, and the coil will continue to turn clockwise. In these videos, we have now discussed electromagnetic induction, electric generator, and the electric motor. So all that we still need to look at is alternating current and how you do calculations with the alternating current.